Good morning. This is the last video for statistics section 4.1. I'm going to talk about some other random sampling methods. Okay, so in the last video, we talked about a simple random sample. And you have to know that how good an idea it is to take a simple random sample. Remember what that means. That means not only does every individual in the population have the same probability of being chosen, but any potential group of size, whatever, has the exact same chance of being the sample that's chosen. So that's great, ideally. But this, as it says here, choosing an SRS can be tough depending on the size, location of the population. Might just not be practical to make a list of all 50,000 residents and randomly pick 30 of them and find them. So just either time or cost-wise, sometimes that's not doable. So this says if the population inherently has groups, one of these two methods is often used. So there are two methods that are both really good and they're both random, but you have to be clear they're not simple random samples. And they both are used when the population somehow already has some groups to it. Depends what the groups look like. So first one is called a stratified random sample. And this sentence is important. If the groups have some inherent differences between them. A couple examples. In a school setting, you could argue that freshmen and sophomores and juniors and seniors have some inherent differences. So that would be a good breakdown of groups to use, or male versus female, depending on what study you're doing. So if the population has freshmen, sophomore, juniors, seniors, but if there are some differences between the groups, these groups are called strata. And what we do is we go to each strata individually, take an SRS within that each strata, and then combine those to make our overall sample. So, for instance, in a school, if I wanted to sample 60 or 80 Northwest students, and I acknowledged, hey, there are some differences, freshman versus sophomore versus junior versus senior. I'd go to each class individually, one at a time, one strata at a time, and I would take an SRS within each strata of size 20 and then combine those at the end to get my sample of size 80. Again, if the population has inherent groups, that's a really good way to do it, to make sure that each class is represented. So this is a really good way to take a sample. If the population has groups, and if those groups probably have some sort of differences from group to group. Within the group, they're similar, but from group to group, from group to group, they're different. That's when a stratified random sample. We take an SRS within each strata, combine those to make our overall sample. That's the first way to do it. Second way is if there are still groups within a population, it's called cluster sampling. If the groups are essentially miniature versions of the population. For instance, let's say I have 200 freshmen and I've just got them divided into groups alphabetically, 10 groups of 20. There's nothing inherently different from one group to the next. Each individual group is kind of like a little miniature population. So if the population is broken into groups like that, where there are groups, but each group is not necessarily different from the other, that's when you use cluster sampling. Each of those groups is called a cluster. So in this case, it says you're going to take an SRS of the cluster. So let's say there are 10 groups of 20 freshmen. I would put like the numbers 1 to 10 in a hat and randomly pick 3 of them. Let's say I pick numbers 1, 4, and 7. I would then go to cluster 1 and 4 and 7 and survey everybody in those 3 clusters. You have to understand how that's different from stratified. Stratified, the groups are different. I want to make sure to get some of each group. In cluster, the groups are the same. This is just if the groups are the same, if the groups are little individual mini populations, and if I just randomly pick a few clusters and go to that cluster and survey every person in that cluster, that's just a real convenient, like that probably saves time or money as opposed to taking an SRS. So you have to be able to recognize, given a situation, whether it's stratified random sampling or cluster sampling, you have to be given a population and understand which type of sampling might be better depending on how the groups are structured. So again, stratified random sampling versus cluster sampling. All right, and then the last thing in this section is what can go wrong once you start taking a sample or sampling and surveying. So several things, you have to be aware of these and be on the lookout for them. First one is called undercoverage. That is, again, I got to list it here. That is when some members of the population cannot be chosen in a sample. If I want a sample of Cincinnatians, the question is, from what list am I choosing my sample? If it's a voter registration list, which is often a list used, not everyone's registered to vote. If it's the phone book, which used to be a pretty good list of people in a population, now more and more people have cell phone records. So sometimes it's unfixable. Like if there are homeless people, if you chose various residences to go ask people, you might be missing them. So it's sometimes unavoidable, but undercoverage is when, for whatever reason, some members of the population just have no chance of being chosen. If I take the whole voter registration and I take a perfect SRS from that, I'm doing the best I can, but if there are people not on that list, there's no chance of them being chosen. That's one potential thing that can go wrong, is undercoverage. Next one says non-response. This says when an individual chosen for the sample, I can spell, can't be contacted or does not respond. So if I take a perfect simple random sample and then I contact 30 people and some of them I can't get a hold of, or some of them just don't answer, my sampling method was fine, but if some just don't respond, and again, be on the lookout, that could lead to bias because maybe who's more likely to respond to those? Maybe people who feel more, like I take an SRS, I send a survey out. We want to know what you think about whatever. Only those with strong opinions are going to respond. That is not a voluntary response. That's when, like a call-in poll where people choose to be in the sample, that's voluntary response. If I pick an SRS and send out surveys, if some people choose not to respond, that's non-response bias, not voluntary response. I mean, they're voluntarily choosing not to respond, but voluntary response has to do with people choosing to be in the sample. Non-response is a sample's chosen well and simple just they choose for whatever reason not to respond. That's non-response bias. Next one is, I think there's just two more here, is response bias. Sometimes people just don't tell the truth. And that should make sense. If I'm doing a survey on drug abuse and I want to know what proportion of Cincinnati residents have tried marijuana sometime in their lifetime, that's a subject people are going to lie about. And there's not much you can promise anonymity. Do the best you can. But you have to understand, depending on the question, some people, for whatever reason, just might not be telling the truth. And you have to be aware of that. And the last one is wording of question bias. How the question is worded can have a strong effect on the responses. And clearly in today's political society, oftentimes people are taking surveys and they want a particular response. So you have to be real careful how a question is worded. I've got an example here. Gun control is a very hot topic in society today. And should there be tougher gun control laws? That's a legitimate question to ask. And it's a legitimate question to wonder how the American people feel about that. I've got two questions here, or two potential survey questions, both asking the same thing, but the way they're worded clearly are trying to lead people to a particular answer. On the left, says the Second Amendment guarantees Americans' right to bear arms. Do you support tougher gun control laws? Well, that first sentence, if you're going to remind people that the Second Amendment guarantees that, sounds to me like you want people to say, no, we don't want tougher gun control laws. On the right, it says, each year, 25,000 innocent people are killed with handguns. Do you support tougher gun control laws? Well, the question at the end is identical. When you throw out that fact first about 25,000 innocent people being killed, sounds to me like you want people to say, yes, there should be tougher gun control laws. So be very careful on how a question is worded and whether or not it might lead to some bias. Remember what bias is. Any kind of bias leads to the systematic either underreporting or overreporting of the response, whatever it is that you're looking for. So that is it for the end of section 4.1. Your assignment is 23 to 42. The last, I think, 5 or 6 of these are multiple choice. The first bunch aren't. Most of these are not short questions. So I gave you until Wednesday to get this finished, so you're not hurrying. I probably will start section 4.2 before then. I'm hoping to get through section 4.2 this week, and when we come back in January to have a chapter 4 test before reviewing for some sort of midterm exams. That's kind of where we are. So, okay, there with my camera. Continue to reach out if you have any questions. And other than that, have a great Monday.